All right, guys. So today we're going to be talking a little bit about sleep. In particular, we're going to be focusing on slow wave sleep. So here I've got up on the screen a uh, expert from one of our lectures, and it describes a little bit about the different sleep stages, you could say. We have awake, stage 1, stage 2. We have awake, stage 1, stage 2, stage 3, stage 4, and we have REM. So really on this, I'm just going to real quick describe what they are. That way, when we're talking about slow wave sleep, you have a frame of reference, right? So what we're talking about when we're talking about slow wave is we're generally focusing on 3 and 4. And it's called slow because you can look and the waves are kind of like this in stage 4. They're a lot slower, a lot longer. And what this is this is the neurons firing. We measure this with an EEG. An EEG measures the electrical activity of neurons, and we have synchronized versus desynchronized waves. When it's like this, when it's long waves, they're synchronized. The neurons are firing in unison. They're synchronized, right? That's where that word comes. Desynchronized would be like when you're awake, where it's crazy, all of them are firing at the same time, or in REM sleep, where they're kind of doing the same. We're going to move on to talk about how slow wave sleep is controlled, but you need to have this in mind to be able to understand what we're going to talk about. So, why do we sleep? Well, we simply sleep because it's good for us, because it helps rest the brain. Um, and one of the particular reasons of why slow wave sleep, since we're talking about that, is important is slow wave sleep is really important for memory, specifically declarative memory. Declarative memory is something that is concrete, that you can declare. 1 plus 1 equals 2, or what the hypothalamus does. Facts, basically, stuff that you could declare, repeat back. So slow wave sleep is really important for that, while REM is important for non-declarative, which is a little more abstract, and we're not going to get into this since we're talking about slow wave sleep. Performance is enhanced in memory and recall when you get sleep, specifically slow wave sleep, and very bad things happen when you do not get the sleep. So let's move on. Let's get to where we're going. So to draw the distance, or to draw the to better differentiate, thank you, between the two sleeps, I want to bring up an example of lights, right? When you are, how do the neurons work in slow wave sleep? Well, when you're, how do they become synchronized? Well, let's imagine each neuron as its own LED light, right? So we have 1, 2, 3, 4, 5. We have a ton of LED lights, right? Because those are all our neurons. Well, when you're awake, each neuron is firing independently, right? And you get basically a rave, right? You get a party, and you get like a strobing light, and that is the experience of being awake, right? You can basically think of it as a strobe light. Now, when you're in slow wave sleep, all of them are coming on slowly, going off slowly, coming on slowly, going off slowly. Kind of like a fireflies when you're watching them in the night, or kind of like those Christmas lights that you can set to fade. When you set the Christmas lights too fast, it's like, oh, you're getting a stroke almost. And that's what it being awake is. But when you set them to that slow on and off, slow on and off, remember that, and you're going to remember how slow wave, how the neurons in your brain synchronize when you're in the slow wave sleep. And it functions by inhibiting your arousal centers of the brain. You see here, I already circled it. The arousal centers of the brain send out neurotransmitters because that's how the brain likes to communicate. The arousal center sends out neurotransmitters to your brain, and okay, the party's starting to go, the lights are flashing, we got the strobe light going, you're awake, you're moving, you're getting to class, you're learning things, amazing. Well, how do we stop that? How do we get into sleep? Well, what happens is you have something called the VLPO right here. VLPO. What does that stand for? VLPO stands for ventrolateral preoptic area. VIPOA. The ventrolateral preoptic area is something that inhibits these arousal centers. It secretes GABA. Now, what is GABA? We can remember that from our previous lectures, that GABA is an inhibitory neurotransmitter. So it inhibits the arousal centers. And so the arousal centers don't send out those neurotransmitters that get us pumping and get all the strobes firing. So then the neurons start firing like the slow Christmas lights, right? So that is kind of what controls sleep, kind of what gets us to fall asleep. Now you're gonna ask, well, why can I stay awake then when I want to, right? Well, there's kind of this communication between the VLPO and these arousal systems in our brain. They kind of communicate. It's like it's like when you're programming, right? For those of us who are really into computers, I know I am, my generation. When programming, you either have a 0 or you have a 1, right? That you can't have both. We're not talking about we're not talking about any crazy what are they called, theoretical physics or string theory. Let's just talk about 0 or 1 binary, right? The binary system. It's either inhibited or it's not. Arousal systems or VIPOA. It's either on or off, one or the other. 1 or 0, 1 or 0, okay? That's how I remember it. It's either one or the other. When you're awake, or if the VLPO is inhibiting, it's inhibiting. But there is something that can come in and it can lock us. It can put a lock. Oh, this is my best thing on a lock on the 1 and keep us there. And that is basically conscious effort, motivation to stay awake. When you have your focus on staying awake, you will stay awake. You lock it into the arousal centers. And that's how you can stay awake for long periods of time. And if you unlock it, if you lay down, if you let your motivation slip, it will unlock, it will shift over to 0, it will change from 0 to 1, and it will start inhibiting those neurotransmitters from the arousal center, and you'll fall asleep. That's kind of how the whole process works in a very simple way, right? That's how it helps me. It's not the word I was thinking of earlier was quantum, right? We're not talking about quantum physics where it could be a 0 or 1 or whatever it wants to be when you're not looking at it. This is binary. Sorry, I'm a physics nerd. That's what helps me understand this. So conclusion, in our last 10 seconds or so, conclusion, get sleep. What's interesting is you actually need less sleep as you get older. But a lot of us in classes right now, we're in our 20s. We're right here. We still need about 8 hours of sleep, you can say. When you get to 80, you can stay up all night, you can party, you've earned it. But right now, get the sleep. Make sure you're getting enough sleep so you can get into that deep sleep, you can get into that slow wave sleep, and you can retain your classes. Thank you guys. I'm Richard Gill. Have a great night, everybody.